Hello friends, how are you? Welcome to my YouTube channel Enlightened Mind. Today we will calculate the electric field intensity due to the uniformly charged rod, and this time we will calculate it on a particular point lying on the axial line of the uniformly charged rod. So suppose we have uh, a uniformly charged rod. That rod is in that particular shape, and as we had done earlier. Now suppose this is the middle point of the rod, and from the center, suppose the total length of this rod is 2a, twice of a. So from the center O, this half length is small a, and other half length is also a, right? And suppose we have a point lying on the axial line. Suppose that point, it suppose is at P, and our task is to find the electric field at this point. Again, we will try to calculate the electric field due to this small point, or this small element, and suppose the length of this element is dx, okay, because that is on the x-axis. Suppose that is the x-axis, so this element would have a length of dx, and we know that the total electric charge on that particular rod is q. So the linear charge density would be q divided by total length of the rod, which is 2a. Okay, so the charge on this particular segment element of length dx would be dq, which is nothing but lambda into d of x. Okay, if you'll put the value of lambda here, so that would be q upon 2a into dx. Okay, so that is our small charge. Now our task is to find the electric field at this point because of that small element dx. So that's electric field supposes the d of ex, and which is nothing but 1 by 4 pi epsilon naught, that we already know. Small charge because of that element dx divided by distance of this thing, and suppose the distance of this particular dx element with the point P is x. Okay, so it should be x square, and of course the uh, unit vector along x-axis we know is I cap. Okay, so now total electric field at point P would be, you have to really integrate that from a point this to this, because this dx you should start from here to here. And now suppose the distance of point P from the center of this rod is suppose r. Okay, and this is small a, so of course uh, that this distance from P to this one, this at the edge of a particular nearer edge of this uh, rod would be r minus a, and the further end or edge of this rod would be this much, which is r plus this much distance, to r plus a, right? Now the task is to find the electric field from here to here, so we have to really integrate or put the limit from r minus a to r plus a, and then we should try to integrate that particular thing. So let us write the value of delta E, which is nothing but 1 by 4 pi epsilon naught, okay, which is dq divided by x square. Okay, integrate from r minus a to r plus a and de. Okay, okay, so some distance take, okay, which is this one. So you really have to change what is d and delta q is. Delta q is lambda into dx, so you can put that value here. Okay, so the electric field would be from r minus a to r plus a, and that is 1 by 4 pi epsilon naught delta q, which is nothing but lambda into d of x, divided by x square, right? So that can be written as, you can take 1 by 4 pi epsilon naught common, take out, and lambda is also coming out because lambda is kind of a constant term, and then you have to integrate from r minus a to r plus a, right? So the term which is remaining here now would be only a small term, which is dx divided by x, I think x square, and this can really could be written as r a r minus a to r plus a, and then x minus 2 into dx. Okay, and this constant term you can write lambda divided by 4 pi epsilon naught. Okay, so that can be written as lambda upon 4 pi epsilon naught, and when you integrate that, I think that would be x power minus 1 divided by minus 1, and limit is from r minus a to r plus a. Now really you have to put this limit and take this minus sign out of uh, this term, so that would be minus lambda divided by 4 pi epsilon naught, and x minus 1 is 1 by x, so r minus 1, that is the r minus a, and r plus a, that is the limit. So you can really write this as minus lambda divided by 4 pi epsilon naught, right? And that would be 1 divided by r plus a minus 1 upon r minus a. So when you take this minus sign inside of that bracket, so that would become lambda divided by 4 pi epsilon naught 1 by r minus a minus of 1 by r plus a. Okay, now you can take LCM of that term, and that would turn out to be the following: lambda divided by 4 pi epsilon naught r plus a minus of r minus a, so r would be cancelled out, and I think 2 would be twice of a, and that term would be r square minus of a square, so that would come out. Okay, and now you can put the value of lambda. Lambda is nothing but q upon 2a, that we already have seen. So you can put this value of lambda here, so 2a would be cancelled out here and only q would remain, so that would be 1 by 4 pi epsilon naught, and that is q. So by 2a is already cancelled out, I already said, so r square minus a square, that is a term. And of course there will be a unit vector which is indicating that the electric field here in this case would be along the x-axis. So here electric field is only along the x-axis, right? So very simple question. So that's the end of the derivation. I hope this would be very useful, and if you like the video, you can click on the like button and share the video. Please subscribe my channel so that more such videos you can see. Thank you for watching my video. Thank you very much.